Hello there, Marek is here, and today we're gonna learn about quartic functions, which means we're gonna study the variation of functions from fourth-degree polynomials. But first I'm gonna introduce you about the steps that you should follow to study almost any function. And then we're gonna take an example of a quartic function and study it together. So let's start. The first step that you should be taking into consideration is to define the domain of definition. Domain of definition for any function. Once you have your domain of definition, the second step will be to study the limits, to calculate the limits. So next step is limits. Third step, once you have done your limits, of course, regarding your domain of definition, you will have to calculate the derivative. Once the derivative is done, you can go to the table of variation. Table of variation. Now, regarding this table of variation, of course, you will need some particular points to add. So the fourth step will be to calculate the coordinates of some particular points, which of course are going to help you to draw the curve. Of course, fifth step, if there's a symmetry, you can study the symmetry. And finally, you will be able to draw the curve. Okay. So I'm going to take an example. We're going to take an example here. All right. So the example is the function fx is equal to 2x4 minus 4x squared plus 3. So this is the function. The first thing that you should be doing is to define your domain of definition. So df is equal to the interval going from minus infinity to plus infinity. Since it's a polynomial, so it's the whole real numbers. The second step is to study the limit. So limit when x tends towards minus infinity of your function, which is 2x4 minus 4x2 plus 3, you can say that it's the limit when x tends towards minus infinity of your highest degree monomial, which is in this case 2x4. Then you will have to do a simple replacement, so it will be 2 times minus infinity to the power of 4. The final result will be plus infinity. Minus infinity to the power of 4, it's plus infinity, times 2, it's plus infinity. The same thing goes to the limit when x tends towards plus infinity of 2x4 minus 4x squared plus 3, which is equal to the limit when x tends towards plus infinity of the same monomial to x4. You will do the same replacement again, 2 times plus infinity to the power of 4. The final result will be plus infinity. Once you have done your limits, calculating the limit, you can go to the derivative. So the next step is to calculate the derivative. I'm gonna calculate. So fx is equal to 2x4 minus 4x squared plus 3. All right. F prime of x, which is a derivative, it's very easy to calculate. It will be 8x3 minus 8x. Now, in order to know the sign of your derivative, which is f prime of x, you should say f prime of x should be equal to 0, which means 8x 3 minus 8x is equal to 0. 8x as a common factor, x squared minus 1 is equal to 0. So the factorized form will be 8x, x minus 1, x plus 1 is equal to 0. So you will have x is equal to 0, x is equal to 1, or x is equal to minus 1. These are the roots of your derivative. And then you will go and do the table of variation. Of course, the values are minus 1, 0, and 1. I'm going to take each factor apart, 8x, x minus 1, x plus 1, finally f prime of x, and then the last one will be the variation f of x. So 8x will be equal to 0 for x is equal to 0. After that value it will be positive, positive, and before that it will be negative. X minus 1 will be equal to 0 for x is equal to 1, positive on the right side, negative, negative, negative. X plus 1 is equal to 0 for x is equal to minus 1, and then you will have positive on the right side, negative on the left side. F prime of x, which is the product, minus times minus plus times minus negative, 0, positive, 0, negative, 0, positive. So the variation will be decreasing, increasing, decreasing, increasing. Of course, you can add the limits, so you will have plus infinity in this case, and plus infinity in this case also, for x is equal, for x tending towards plus infinity. All right, I'm gonna simply write it down again. So increasing towards plus infinity. All right, in this case, as you can see, you have a minimum, a maximum, again a minimum. So you have 3 extremums. We're going to calculate for each value, of course. So the next step will be fx is equal to 2x4 minus 4x2 plus 3. The values are f of minus 1, it will be 2 plus 3, 5, minus 1, minus 4, so it will be 1. F of 0 is equal to plus 3, this is the maximum, so this was for f of 0. F of 1 is equal to 2 plus 3 is 5, again minus 1, it's 1. We can calculate for other values also. F of 2, let's say, it will be 16 times 2, 32, minus 16. So it's a value which has, it will be higher than 10. So I'm not going to be interested in these values. So why not, I'm going to just complete my graph taking into consideration these particular points. So minus 1 is 1. This is the minimum. For 0 it's 3. This is 2, 3. So here we have the maximum. This was the minimum. And then for 1, it's again 1. So our curve will have this shape. It's decreasing, minimum, and then maximum, decreasing once again, minimum, and going towards plus infinity. Okay, so this is the shape that I will be having for my curve. All right. Just 1 second. All right. Now, as you can see, this curve, it has an axis of symmetry. In case we're going to talk about it, it's this axis of ordinates. It will be an axis of symmetry. We have 2 inflection points in this part. It's the first one, this is the second one. If we're going to study about the numbers of roots that this function has, as you can see, the curve which is in green does not intersect with the axis of x prime or x. It does not have any intersection with x prime or x, so it will not have any roots, and we can verify that in another way, in another method. So I'm gonna just give you another method to calculate the number of roots. F of x, it's 2x4 minus 4x2 plus 3. Since you want to calculate the number of roots, you can simply say that this one is similar, this equation is similar to a quadratic equation. You can say let x squared be equal to capital X. So your equation will be 2x4 minus 2x2, excuse me, minus 4x plus 3, which is equal to 0. And then once you will have to go through delta, delta is equal to b squared minus 4ac. Of course, in this case, it's minus 4 to the power of 2 minus 4 times 2 times 3. So you will have 16 minus 24, which is minus 8, and it's a negative value. Again, it shows that this equation will not have no real solutions. That's why my curve does not have any intersection with the axis x prime or x. As for the axis of symmetry, if I'm gonna verify x is equal to 0, is it the axis of symmetry? You can simply use this formula, f of 2a minus x, is it equal to f of x? Okay, now in this case, x is equal to 0 will be a, which is equal to 0, so f of 2 times 0 minus x, will it be equal to f of x? F of minus x, is it equal to f of x? I'm gonna do a simple replacement, so it will be 2 times minus x to the power of 4 minus, so our function was minus 4 times minus x to the power of 2 plus 3, is it equal to 2x4 minus 4x squared plus 3? Yes, in this case we can say it's the same. 2x4 minus 4x squared plus 3 is equal to our function. That's why we can conclude that x is equal to 0. It's an axis of symmetry. Okay, what about the inflection points? So if we're gonna calculate the coordinates of inflection points, it's very easy. You will have to go through f double prime of x. So f of x, f prime of x was equal to 8x3 minus 8x. So I'm gonna calculate f double prime of x is equal to 24x squared minus 8. So f double prime of x is equal to 0, which means 24x squared minus 8 is equal to 0. We will have 3x squared minus 1 is equal to 0, which means 3x squared is equal to 1. X squared is equal to 1 over 3. We will have two values. X1 is equal to minus 1 over radical 3, square root of 3. X2 is equal to plus 1 over square root of 3. So these are the abscissas of the inflection points that you're gonna have. So we're gonna get back to our function. As you can see, one of them has a negative value for its abscissa. The second one has a positive value for its abscissa. We can of course calculate the ordinate also. That's gonna be another form of calculation, just in order to have the coordinates of the inflection points. So that's all for the quartic function. In this case, we were studying quartic function. We talked about the axis of symmetry, point of inflection, the number of roots that you can have. How are we supposed to calculate these roots whenever they exist, etc. So these are the things that we were able to discuss. Yeah, that's all for today. I hope it was helpful, and next time I will be posting other videos related to other kind of functions. So why not? You should be subscribing to my channel, and once you subscribe, you will be able to get notifications whenever I'm gonna upload new videos. I can also share with you my Instagram or Facebook account. You can contact me, leave a comment, or simply contact me through my accounts. I hope you enjoyed it, and see you next time.